Hello, Algebra 2. Gonna make a quick video here reviewing the first 10 problems of the ACT practice test that we got here, and then we'll focus on 10 problems in class. So let's take a look here. A 5 by 7-inch photograph was cut to fit exactly into a 4-inch by 6-inch frame. So a 5 by 7-inch photograph was cut to fit exactly into a 4 by 6 frame. What is the area in cut off? So we took this 5 by 7 and cut it into a 4 by 6. So what is the area of the part that was cut? And subtract away this portion to see how big the remaining portion is. Does that make sense? So 5 by 7 photo, and then 4 by 6, 24. That's the area of the new was 11 square inches. That is C. A line contains the is between points A and C. Point D is between points C and B. So a line, quite a mouthful there. Point B is between A and C. Here's point C. And point D is between points C and B. Oh, so D is between C and B. So actually I want to do something like this, right? So reading that one more time, B is between A and C, which it is. It's between them. But D is between C and B, which it is. Which of the following inequalities must be true about the lengths of those segments? So BC is less than AB. BD, which of the following must be true? That's the important part, right? So the must be true part. So BC is less than AB. BC is less than AB. Not necessarily. The way I've drawn it, it's actually bigger, right? The way I've drawn it, it's actually bigger than AB. So I don't think that must be true. BD is less than AB. So BD is part of, BD is less than AB. Again, not necessarily true, right? I mean, I just drew this casually, right? I mean, like, this visually makes sense, and this easily could have been 4 and 4. That doesn't have to be true. When we stumble upon the answer, you'll know why it makes sense. BD is less than CD. BD is less than CD. That one is the correct answer. Why? Because BD is part of BC, right? BD has to be shorter than BC because D always comes in between B and C, right? How can D be between B and C if it's actually further away? You get the logic that I'm saying there? This has to be smaller than this because it fits inside, no matter how you draw it. So option H must be true. Oh, I read that. Oh, no, I read that as BD. I'm sorry. I read that as BD. So that one is, sorry. What a bad video that I'm making. That's not true. I read that as BD. My brain was thinking BD. So, for the same, okay, what I was just saying is true about K. Maybe I read K or something, right? What I was just saying, right? CD is part of BC, right? This has to be smaller than this. The part has to be smaller than the whole. The part has to be smaller than the whole. Okay. I think my explanation made sense. It's just that I had a brain fart and said it. If x and y are positive integers such that the greatest common factor of x squared, y squared, and xy cubed is 45, then which of the following could y equal? Okay, so let's read that again. If x and y are positive integers such that the greatest common factor, so we know what GCF is, right? The greatest common factor of these two is 45. Then which of the following could y equal? So instead of thinking about like random numbers, I want you to compare these two. What is the GCF of these two terms? What is the GCF of these two terms? The GCF is x y squared. They both share an x, and they both share two y's, right? Does that make sense to you? So somehow this has to be 45, right? This has to be 45. So x could be 45, right? So this combination has to be equal to 45. What are the options that could possibly be true? X could be 45, and then y is 1, because y squared, 1 squared is 1, so 45 times 1 equals 45. So the GCF would be 45. Or x could be, what else? X could be, what's another number that goes into 45? It could be 3, right? So this could be, oh wait, now I'm confusing myself a little bit. This has to be a perfect square, right? So, 5 goes into 45. 5 times 3 squared equals 45. I'm just kind of like messing with the numbers a little bit in my head. I know I didn't do a very... Thinking is like, okay, y could be 1. 1 squared is 1, so therefore x has to be 45. 45 is not divisible by 4, so I can't do 2 squared. But what's 3 squared? 3 squared is 9. 9 goes into 45. So then therefore x is 5. So y could be 3. Does that make sense? I'm sorry. We could talk about that in class if you have a question on that. To test a new medicine, each of 300 volunteers was assigned a distinct number from 1 to 300. Next, a calculator was used to simulate drawing 150 balls from among 300 congruent balls. The balls were numbered the same way as the volunteers, so that 150 volunteers to receive the new medication would be chosen without bias. The other volunteers received a placebo. Weeks later, the two groups were compared. Which of the following phrases best describes the company's testing? And they were randomly chosen via the balls, right? So it was random, definitely random, okay? There was nothing non-random about this. It was a luck of the draw type situation. And is this an experiment, a census, or a survey? Well, it's definitely, when it comes to like testing drugs, you can just immediately assume practically that it's an experiment because there's a placebo group, right? If there's a group that's not receiving anything, and then there's one group that's receiving a treatment. Anytime you're giving a treatment, it's an experiment. That was one of the key words that we talked about in our stats and probability unit. One caution sign flashes every 10 seconds. At a certain instant, the two signs flash at the same time. How many seconds elapse until the two signs next flash at the same time? It's about the least common multiple. It's all about the least common multiple. If something's flashing every 4 seconds, when will that be a multiple of 10, right? 4, 8, 12, 10, it's not, none of those are at the 10-second mark. 4, 8, 12, 16, 20, right? Finally, we find that multiple of 10. So at the 20-second mark, boom, they will go off together at the same time. It's all about the least common multiple. We're at the 10-minute mark. I didn't want to go too long, so maybe we'll see where I'm at about the 12-minute mark. For all non-zero values of a and b, the value of which of the following expressions is always negative? For all non-zero. So we don't know whether a is positive or negative. We don't know whether b is positive or negative. We just know that it's not zero. So the question is the answer to this always going to be negative? The best way to think about this is with counterexamples. I could easily do 3 minus 2, and that's positive 1. That's not always negative, so that's silly. That's out. Is this always negative? So those are both negative, right? Well, if it's if a is negative, well, negative 10, for example, minus 2, oh, well, that's 10 minus 2. So that's also positive, right? So that one's out. If we take the absolute value of two things, well, it's just making everything positive, so that can't be possibly right. Now, you might be like, well, Mr. Skews, aren't we taking the absolute value of all these other ones? Well, this is positive and positive. A positive absolute value is going to result in more positives. But what about this? We get the same situation. If I take the absolute value of 3 and the absolute value of 2, I'm still going to get 3 minus 2. So that one's out. But this one, if you take the absolute value of any number and you make it positive, but then all of a sudden you make it negative, right? Taking the absolute value of any negative number will result in a positive. But I'm applying a negative to that positive number, hence making it negative again. Right? So that's my answer. Okay. I want you to enjoy as best you can watching these and not feel overwhelmed by all these problems. So we'll stop with 6 problems. I didn't ask a question, but I do want to know that you watched this. So let's ask just a random question here. Which one did you find most difficult? And I'll have a question 1, 2, 3, 4, 5, 6, 21, 22, that represents 2, 23, 24, 25, or 26. Which one did you find most difficult? I'm just curious. Thank you for watching. Thank you for wanting to study and review this during the weekend. So have a good rest of your weekend. I'll see you.